Engineer-inventor Dellis has always worked hard with his hands starting in the 70s, racing AMA motocross all the way up to today, building and racing his Blister Corvette lightweight racer, number 007. He's never been afraid of experimenting with anything that can lower his lap times. However, it was a fateful day in 1987 that would change his life forever. Aboard a turbocharged motorcycle at 140 miles per hour, he got arm pumped from hanging on so tightly. That moment became the inspiration for his twice-patented invention, PersonaGrip. This paradigm-shifting invention changes how hands interact with objects. Instead of needing to squeeze things, carefully designed pieces of thermoplastic can act as levers, removing the need to waste energy squeezing objects for control. In manufacturing, its EMG proven tenfold decrease in risk for carpal tunnel syndrome, reduced costs, and increased profits for GM, Ford, Chrysler, Toyota, Kenworth Trucks, Harley-Davidson, Hewlett-Packard, Campbell Soup, and Seba Vision, just to name a few. In racing, that same 54% reduction in grip effort translated into a victory its first time out, with serial number 1 steering wheel finding the victory circle at the 1993 Indy 500. For the rest of the season, Emerson Fittipaldi's previous mid-teens finishing positions transformed into 2 more wins and 7 podiums by cutting his lap times while being safer, often just inches from walls, at well over 230 miles per hour. Teams and drivers across all forms of racing have discovered that good steering wheel ergonomics goes well beyond what meets the eye. In fact, poor designs can bite back when thumbs get trapped during kickbacks, much like modern steering yokes do today. However, properly designed PersonaGrip on yokes can significantly improve safety, not only during kickbacks, but also when racing at the cornering limit. It accomplishes this since less forearm tension improves the signal-to-noise ratio on the steering feedback signal, which precisely follows the front tire's mu-slip curve. So drivers are now able to race with greater precision and stay safely under the limit, since they can more easily tell when the front tires are at the cornering limit. The steering resistance peak feels sharper in the driver's mind since it's more clearly defined from the reduced forearm tension that was previously blocking small changes in feedback. Their increased confidence translates into closer racing action and improves the racing product for both sponsor and fans alike. So what's the problem? Moldable material is like paint is to a painter. Just because you have paint doesn't mean you can paint. While genuine PersonaGrip steering wheels have decades of endless experimentation and forensic safety analysis, using feedback from the world's best drivers baked into each design, beginners can unwittingly create grips that are moderately effective at best and potentially dangerous during kickbacks at worst. What's the solution? Inspections during tech can fix poor designs today, and eventually new PersonaGrip hybrid designs can make racing safer and better for tomorrow with all safety features already built in. While PersonaGrip hybrid designs are being tooled up for production, tech inspectors at the track can simply check top wing designs for thumb entrapment. Fixing poor designs with non-remoldable materials simply involves cutting off material, while remoldable materials like PersonaGrip can be reheated into a safer design on the spot using a heat gun. As the pendulum swings today, PersonaGrip hybrid designs should be offered at the OEM level. During the transition stage, yokes can be retrofitted and made safer with impact surfaces modified with shock-absorbing materials that are designed properly for thumb egress during kickbacks. Outside flat surfaces can be modified as well. Properly designed low modulus design elements falling into the 50 to 60 range can be applied to the thumb areas and outside surfaces of yokes today. This density provides sufficient impact resistance while allowing near instantaneous steering response according to driver input. To avoid blisters, any surface in contact with the driver's gloves should avoid sharp edges. A profile guideline for cantilevered design elements should follow a profile defined by a 10mm rise, with an included angle of 30 degrees. Tip radii should be no less than 2 mm for durability. Unobstructed thumb egress requires no sharp edges on the backside of the top edge on the horizontal spoke. This area should consider the radial area of the thumb tip closest to the body as it exits the wheel during a kickback. This design also requires a recess downward towards the thinner eminence. Additionally, there should be no interference on the thumb tip ulnar area as the web between thumb and index finger rises along the inner circumference and moves outward across the face of the wheel while exiting. This design also requires a relatively larger radius upward at a 45-degree angle towards the face of the wheel in the web area. All PersonaGrip wheels designed today include these safety features, plus many more that avoid friction blisters. Thank you for watching, and be safe.